Hello. So let me finish the question list for the closed book part for Exam3 in this video. So in class, we finished the question 29, and then we have questions 30 to 45 to be finished, right? So here, question 30. Is the sign of the Pearson coefficient R determined by the sign of its numerator or denominator, right? So you can find the answer at page 492, which is the Pearson R, the formula. Let me see the formula here. As this. We know for the Pearson correlation R, we can have either a positive number for a positive relationship or a negative number for a negative relationship, right? So it means its sign can be either positive or negative. And for its denominator, the denominator is the square root of something which is always positive. So the sign of R is determined by the sign of SP, right? Which is its numerator. SP is the sum of products. Pearson efficiency followed what kind of distribution? So this one is talk about the distribution of R. We need this to determine the critical region. So go to the page 508. I can tell you the answer. It is a T distribution. For the T distribution, just go back to chapter 7, right? For what's the shape of the T distribution. If we predict a positive relationship, means we have the direction in our prediction, right? So this one is a one-tailed question. So for t-test, if it's a one-tailed prediction and we predict a positive value, means for the t distribution, right? Because the R follows a t distribution. For a t distribution, the positive value is the right side of the distribution. Here, the R square is a measure of sum of what, right? So you can find this at page 500. R square is a measure of proportion of, this is a definition of this one variable that can be determined from the relationship with the other variable. So means the proposal of one variable, we call it as y, that can be determined by the other variable, for example, x, right? Because it's a proportion, so its value will be never negative, and this is from 0 to 1, 0% to 100%. So this one, we talk about the Pearson correlation and Spearman correlation. So though both of them are computed for the same data set, if the Spearman correlation is equals to +1, and then what can you conclude about the Pearson correlation? Actually, it's a learning track question, right? Can be found at the page 519, and we can go back to check these pages for the computation of the Spearman correlation. So we just said the Spearman correlation can describe the chain of the relationship, but its magnitude or its strength will be different from the Pearson correlation because we ignore the actual number. We just we transform them just into the rank. We just focus on their relative relationship, means the rank. So we said the Pearson correlation can reflect the chain of a Pearson correlation. So means if the Spearman correlation is positive, and Pearson correlation will be also positive. So the answer is it will be positive. But we cannot know the Pearson R, what's the value of Pearson R, because we don't know the actual data. For this one, for Pearson correlation, right, we have a set of data x and y. If we change one of the last score, means this score, the 5 to 100, where the Pearson correlation change and where the Spearman correlation change. So the Pearson correlation, think about the definition of Pearson correlation, is computed, right, according to based on the variability of the data. So if we change to the 5 to 100 and the variability increase, so the Pearson correlation coefficient, what? Pearson correlation efficiency will change because we change the variability of the data. However, the Spearman correlation just take the rank into consideration. So even though we change the 5 to 100, it will be still on the 5th rank, right, of the X, because we rank the data from the smallest to the highest. So its rank doesn't change. And then Pearson correlation will not change. So no, the Spearman correlation. Next question, right? In the general linear model, y equals to bx, b times x plus a. The value of b is called. So this, and the value of a is called. So this is about the definition of linear equation. So go to the on the slope. And the a is called the y-intercept. The least square solution is the algorithm to identify the check page. Right? And then you can know it's an algorithm to identify the best fitting regression line. It. For regression, the standard error of estimate give a measure of the, so it's the definition. Check page is the distance, standard distance between the predicted y and the actual. So this one, the contribution of regressors in the prediction. Check P is evaluated by the R square, right? The R square here gets the square of the Pearson correlation R. Into the same R square. We just have 5 questions. This one is the learning check question at page 442, right? You can also check page 44 for its solution. So this one, just simple math, y equals to b1 times x1 plus b2 times x2 plus a. This is the equation. So b1 equals to 2 times x2 equals to 2 plus b2 equals to -3 times x2 equals to 4 plus a equals to 7. So solve it, which is -1. Please list the parametric and non-parametric tests we learned in this semester. So the parametric test, definition of the parametric test and definition of the non-parametric test. Check your page. The parametric test, we have some assumption about the distribution of the parameter of the population. And their data are usually the numbers, means the numerical data. But for the non-parametric test, right, we don't have any, or we just have few assumptions about the distribution of the parameter. and their data are usually the categorical data. So most of them statistic tests are the parametric tests. For example, the Z-score, the hypothesis testing test, right? The Z-score, the t-test, the ANOVAs, and the Pearson correlation, and linear regression. So if you read this chapter, right, you can find every chapter we have a section about called the assumption of this test. So it means they have strong assumption. So they are parametric test. And the non-parametric test, we just learned 2 in this semester. The first one is experiment correlation. Here, we don't have assumption of the distribution. We just focus on the rank. The rank is the ordinal data, not the numerical data. And another one is the chi-square test. So here, we just focus on the frequency, which is the categorical data. The data for a chi-square test of goodness of fit is called, we learned this one in this Monday. Check page. Observed frequency. So this one, the shape of the chi-square distribution and the critical region, right? You can find it at, where is it? Is symmetrical or normal or positively skewed or negatively skewed. Negatively skewed. And the critical region is similar as the f-test on the right side of the distribution. So this one is a learning check question at page, and also you can see the page 564 to 565 for it's their definition. So their relationship is, oops. Fe is the observed the expected frequency. Fo is the observed frequency. The sum of each equals to n, which is the sample size. How many subjects in total? The last question, yay. So this one is about the 2 versions of the hypothesis for chi-square test. 2 version H0 for the chi-square test of independence. So if A and B are independent, the shape of the distribution of B in A1 category is the shape distribution of B in the A2 category. You can read this part, the equivalence. because the two versions are equivalent. So one version is A and B is in the null hypothesis is one A and B are independent. The version 2 is the shape of a factor is the same at different levels of another factor. So we finish off the questions. And if you're not in the class today, I can show you page by page for the answer, so you can take notes also. Or I'm not going to repeat everything just for you, and I will not upload this one to the Applia. So here, give you some time, you can press the stop button and then to take notes. The first page, the second page, the third page, the fourth page, the fifth page, sixth page, right? So we went through 30 to the last page. Okay, we are done. Thank you for watching the video and hope everybody can have a good score in the final exam. See you next week.